So first, I would like to control this Mp3 player serial by this microcontroller, an STM8S103. This is the Swim programmer. But first I want to control it through serial port. This driver of this device I got from China, but I can't get it to work. The device is not recognized in Windows 10. Whenever I connect the device managers say it is an unknown device. I removed, uninstalled, installed all kinds of drivers, CH340, 341, CP2101, whatever, but it does not recognize this device. So I finally quit using this adapter. I had to make a new cable. I use this one. I'm sure it is recognized by Windows. I want to know the information, the pinout of the Mp3 player, DF1 player, how it's called. I use shortcuts. Alt Q is done by auto hotkey. It's not working fine now with the last Windows update. Normally my icons on the desktop disappear. Only when I push F6 it returns, but within a week, last update, they don't disappear. But anyway, Alt Q, I get everything. I'm calling it, yes, everything. That is a search program that goes very fast. It finds every file you want to find. I am an old person. I experience with Windows XP. You can find any file. You can find any contents in any file, in an exe file, in a doc file, whatever. Since then, Windows search facility is horrible. It doesn't find files, it doesn't find content in a file, it's just horrible. That's my experience. So I use this file just to, this application, everything, to just find file names. How to find any project. I mark all my projects with a text file that starts with hvw, that's my name, Henk van Winkoop. Then the year, then the month, then the month, day, and then the hour and the minutes, so it's 12. So I put a text file with this hvw date time notification, but with all kinds of information you can remember to find something, and I call this text file not .txt but .plh, oftewel placeholder. I want the information, the pinout of my Mp3 player. I just type in somewhere it's DF1, I know, and then PLA player, Mp3, and always PLH, placeholder. And I think I find then my placeholder, and I go opening this folder, open. I have to look at the clear open path. Yes. Well, then you go into my folder where all information is about this Mp3 player. For instance, I have made some pictures in it. You can see this one, you know, okay. But also I made always my own description of it, or this one, the pinout. I made it always in a simple ASCII file, which is very informational. Not a good example how I normally store data. I made all kinds of subfolders like pictures, audio, text, whatever, PowerPoint presentation, but now all is in this simple folder, because I'm starting with, I have a document which also shows the layout of the MP3 player. There are no special rules for wire colors, but normally the ground is black and the VCC or the plus is red. But as we have 5 volt and 3.3 volt, I use the red for the 5 volt and the less red, orange, for the 3.3 volt. Then I make myself an appointment to myself how to use wires. You can see for the audio and for the TX, RX of the serial port. The TX is always yellow. This is geel, but that's in English is yellow. This is green, TX. So the yellow is the TX, but the TX is always meant seen from the device. So the device receives something from the USB cable and then it transmitted, the TX is it to the Mp3 player. This is the TX is a yellow and it goes, and it should be connected to the green wire of the Mp3 player. Also the green one is the RX, this the data is going this way, going out to the USB. So I made for myself some appointments. I communicate with RS485, maybe you don't know, but you have an A and a B line, and to remember, A is amber, amber is like orange, this is orange in Dutch, and B is blue, blauw, blue in Dutch. So you can see at the color of the cable, you can see is it signal A or is it signal B. So I made my own appointment about serial communication, yellow TX, green RX. Also with audio, gray and white. These are the colors of the wires. These are the same colors as are on resistors. I use this system. So the gray is the audio. It seems here audio left, audio right, but it's not totally doesn't function. This one is always used. I use as ground, and this uses the audio. So you have to rewrite this document. But anyway, I created a new connector. I use single wires and I glue them together with this glue to make one connector. Now you can see the result. The data cables are connected. The 5 volt is connected. That's coming from the USB adapter. Go to that. And the 3.3, there's a regulator on it that makes 3.3 volts from the 5 volt, but we don't need that, so I put it in here. Then I connected my computer to this USB interface and I started a hyperterminal. Hyperterminal is my favorite old program. You can PuTTY or maybe there's some new programs, but I'm used to get a hyperterminal. I set it to 9600 baud, and if I just press any key on the keyboard, I get some response. It's in ASCII, but you can see there is communication between my computer and the Mp3 player. Hallelujah. Well, I had prepared some files to be sent. You can do transfer and then send text file, which I had prepared. Prepared command play folder. Oh, these are all play folder whatever. As I use.
Vraag 1, ja of nee.
So it plays the WAV file that is on the SD card that is inserted in here. Depending on the instructions, I send it with some text command by hyperterminal. So this whole installation is working. I will then extend this video if I succeed to control it Mp3 player not by hyperterminal from the computer, but from this microcontroller. And this microcontroller then also is controlled through serial port. Data is not going directly to the Mp3 player, but it's going to the microcontroller, and the microcontroller then controls the Mp3 player. So within hyperterminal, within my console, in the software of the STM microcontroller, I can make a program to control what WAV file is played on the SD card. But I will explain later if it all works. So I now mounted a new USB RS232 device onto my system. Now I have to find 6 wires, these are 6 connections. I sorted them here out, and well, it looks like a mess, but this normally is my storage of these wires. I have a 10 centimeter, 20, 30 centimeter, male, female, female. And I have a special one with only black and red for power supply, but this box is used to sort all things I dismantle. I threw it in this box and I just sorted it out in 10 centimeter, 20 centimeter and 30 centimeter, but I have to sort it out again on color one time. This new device, or this other device, number 2, serial USB, which I will control the microcontroller. Here is the pinout. These are 6 pins, grounds, RX, TX, 3 volts, and the 5 volt and VCC if you put a jumper here. Otherwise 2 diodes are between the 5 volt and the power of the chip. So it makes a drop of 2 times 0.7 volts, 1.4. So from 5 volt it gets 3.6 volts to the chip and also to the RX, TX data levels. I have to find out if the TX to the microcontroller, which is powered by 3.3 volts, if it isn't too high, so I have to make some resistance or whatever to make it level out. Anyway, all my projects I give a number. I always talking about HVW, but it means HVW. V is Dutch. W, HVW. First, let me put off the fan. Excuse me. So now I made a new connector. You can see that the orange is a little bit shorter. It's another type of connector, I don't know. But anyway, here I have some stuff on this board I just experimented with. There's a switch and another switch. This is very tricky. It is not stable. This is, but it is not working. It's difficult to switch it on, switch it off. So I will remove these items from this board before going on. The nice thing about this Lego system I use is that you can simply remove items or add items, whatever. These wires are meant to be in the microcontroller, the STM8S103. There is a beeper peripheral, and you can use this to activate a beeper, where you can put it's a digital beeper. Well, I must tell you something interesting about the STM8S103 board. Here's another one. I bought many of them. The ground of the system of the chip is not connected to the ground of the USB. So you also have to plug in the USB to get it powered up. But I just want to like it to be powered by the debugger. So what I did, I made a modification to it, connecting the ground. Can't get it up. The ground of the USB connected to the ground of the Swim programmer debugger. So now I can just use it, leaving the USB open, and it is powered by the ST-Link V2 programmer debugger. So now I want to know the specification of the input voltages that the RX pin of the microcontroller can handle when this USB RS232 converter delivers 3.6 volts. Go to my computer, it's Windows D to remove all, Alt Q to my finder, and then I type in STM8S103, and it's about data sheet, so I say data and then placeholder eventually. Oh, there's no placeholder. I did not put a placeholder. But anyway, where is it? There is a pinout, datasheet pinout, the datasheet. And we have to find the voltage characteristics. I opened this side thing, and then this electrical characteristics. Okay. There we find the absolute maximum ratings, and then it says Vin on true open range on any other pin, maximum VDD plus 0.3 volts. VDD is 3.3 volts, plus 3 is 3.6. That is exactly the voltage that is delivered by the RS232 USB interface. Dus theoretically it's allowed, but it's on the border. I like things to be clear. This is a yellow wire I put in here. It's just an indication, not some connection, because they are already connected, but it's connected to D5. It's a yellow one. For me, the yellow one is the TX of the microcontroller. The TX point wire, pin number 2. I must confess, I made my own pin-out numbering. Like all digital analog chips, I start left with pin 1. So I said to myself, on the USB, this is pin 1. It goes around until pin 10, 11 to pin 20. So this is pin 1 and this is pin 20. I want to indicate each pin on the breadboard, so I need the RX, a green wire, to indicate this position. I'm going to find storage. I made a lot of these wires. I have to look if I can find. Well, hey, there is a green one, so we will use that as an indication for the RX signal. So there it is, TX, RX, seen from the microcontroller. TX, RX. So I finally cleaned up the whole project, removed unnecessary things. The 5 volts from the debugger is not needed because, as of my modification of the hardware, this wire, I do not need a USB. The microcontroller is powered by the 3.3, the orange cable. of the interface, RS232 interface. If I connect these together, the TX output will be 5 volt. Now it's 3.6. It's at the maximum that is allowed at the input of an STM. So I take a risk, but okay, we'll do that. The 3.3 going out is not used. Only the TX and the RX, the yellow and the green, are connected to the opposite color. The green to the yellow, and the yellow is connected to the green. So this should work serially. But to check if the system is already good connected, I'm going to find a project where just the onboard LED of the STM is blinking. All my projects, I have an application folder and a document folder. The document folders I always update each week or whatever. The application I go to have a backup. These are my backups. Each time I made a few changes or important changes in the software, I then noted the day and the time I did it, and also the date and the time where the previous version was executed. So you see here 1922, it refers to something, and that is the one above. The disconnection should always be there, and I put some information about what is happening. So here I find a busy one moment. Well, let you tell me how I handle my projects. Each project has its own folder, and in there is a subject. To me, is the semi-RTOS. It's not a real operating system, but it's not straightforward. It's semi. It's my own invention. It's not that interesting, but anyway, I have backups of each project. I have a shortcut to backups, and you can see this is all in Dutch. Each backup has its own year, month, date, time, minutes, and Z is you can read it as look at. It's derived from this one. So this one should be this one. And you can check if all these connections are real. So this one about the 1232, C 1100, this should be 1100. So I can control that all my developments are connected together. And I have here onboard LED toggle semi-RTOS basic, whatever. You can open the zip file. Then I go back to my development. It should have the same name. It's not exactly. I change it, so I remove this folder. Yes. And I say semi-RTOS basic, move it to here. I always make my zip files read-only, so I don't accidentally remove this file from a zip file. We open this folder, we see the project file, stv, opens, closes, opens again, and I downloaded it to the microcontroller. It's going to download, and it's going to run, and look, the microcontroller LED is onboard LED is blinking. It's a proof that the program is downloaded and it all works fine.